Well, now that we have explored magnetism, let's take a look at electricity, which is the other part of an electromagnetic wave. So, electricity. What is static electricity? Let's just start with static electricity. So, static electricity starts when you have an object that has either an excess or a lack of electrons. And because electrons will want to even out as they come into contact and remain neutral, you will get a massive movement of electrons from one place to another when you bring two things in close contact to each other. So atoms are normally neutral. They possess the same number of protons and electrons. Now, I'm not going to say that they're actually normally neutral because most metals particularly will tend to lose electrons and be positive, and most nonmetals will tend to be negative most of the time. That's their most stable setting. But so electrons can be transferred from one object to another if they're rubbed together. So when you rub two things together and electrons are passed from one thing to another, that the one with the excess electrons now has a negative charge, and the one with the lack of electrons is going to have a positive charge. So those unlike charges are going to attract each other, and like charges repel each other. And so when you bring two things close together, the electrons are going to jump in order to make the positive thing neutral and in order to make the negative thing neutral. And so you get this jumping of electrons, in which you'll actually see a jump of electrons as a spark. And this is static electricity. Lightning essentially is static electricity. But you get the same thing, especially in the wintertime, when you comb your hair. If you comb, now obviously I don't have this issue, but you comb your hair, and what you're actually doing is you're going to be rubbing electrons off of your hair onto your comb. And when that happens, you can actually create static electricity and cause your hair to stand up. Or if you took a balloon and rubbed it on somebody's hair, and you can then create static electricity that way. Um, So when you comb, electrons are transferred from hair to the comb by friction. And so this results in a negative charge on the comb and a positive charge in your hair. And so as you hold the comb close to your hair, the positive and negative charges will attract each other. And so it will pull your hair up towards the comb. So the atom gains or loses electrons, and so you end up with negative ions and positive ions. And remember what we've talked about before with metals. Metals will tend to lose electrons and become positive ions. Non-metals tend to gain electrons and become negative ions. And so anytime you have an addition or lack of electrons, and so you have a charged object or a charged atom, what you have are called ions. Now, electric current is a little bit different because electric current is the flow of an electric charge. It's the movement of electrons through a wire or through some sort of a conductor. That's an electric current. Current is the rate of electrons that are traveling through a conductor. Okay, direct current means that they're moving in one direction only. Electronic devices that use batteries and stuff like that, those are direct current. Alternating current, AC, is when the electric field moves back and forth through a wire, and the current flowing, it flows one way and then it changes and flows back the other way. The current that we have in your house is alternating current. Alternating current is easier to work with because it doesn't dissipate over distances, and that's why the electricity that comes into your house is alternating current. So an electric circuit is required in order for electrons to actually move. You actually have to have a completed circuit. There has to be a complete pathway in order for electrons to travel. First, you have to have a source of electrons. Typically, that's going to be like, for instance, if you have a battery connected to something, the battery is going to be a source of electrons. And then you have to have a place for those electrons to go, and that completes the circuit. So the electrons that are in the battery, that they're going to be coming out of the battery, going through the circuit, and then back. So it creates this one one complete circuit. So the charge moves out of one terminal through the wire and back to the other terminal. So as the electrons flow from high concentration to low concentration, then you will see this electrical current being formed. For instance, here in our source, in our diagram, we have the source of electrons, which is the battery. So the electrons are going to be flowing from this terminal through the wire into the object, whatever it is that we need to run, or the resistor in this case. It's going to light up the light bulb, and then the electrons are going to continue flowing through the conducting wire into the sink, which is the other side of the battery. If we opened up this circuit anywhere, then it's going to open up the circuit, the electrons won't be able to flow, and so there won't be any type of a circuit. The electrons won't flow. So when we're looking at an electrical circuit, there are certain terms that we have to look at. An ampere. This is a unit of electricity, essentially. The number of electrons passing a particular point in the conductor in a specific amount of time. Voltage. Volts are the amount of pressure on the electrons to move in a conductor. In other words, this is how much push the electrons are actually have. And then resistance is the opposition to flow of those electrons, the opposition to that flow. So we have amperes or amperes, which is the amount of current. So this is a unit of electricity. In other words, the number of electrons passing through the point, a particular point in a conductor. Voltage is the amount of pressure pushing the electrons through, and resistance is how much the opposition to the flow of electrons there is in something. This creates something called Ohm's law, where voltage is equal to the amps multiplied by resistance, or the current multiplied by the resistance, where resistance is in units called ohms. So current is equal to voltage divided by resistance. So how much current you have flowing through an electrical current is equal to the voltage, in other words, how much pressure there is, divided by how much resistance to flow there is. So here is Ohm's law. The current is equal to the voltage divided by the resistance. Conductors versus insulators. Conductor is something that will allow electrons to pass through it with little resistance. Most metals are conductors. Metals will be conductors of both electricity as well as temperature. Okay, and we've talked about the fact that heat energy will flow from an area of high concentration to low concentration, and metals tend to be very good conductors for heat transfer by conduction as well. So, but as far as electricity goes, this is why we have wires that are made of metal. You know, wires that are made of copper, silver, gold, aluminum, because non-metals tend to be not conductors but insulators. These are materials that resist the flow of electrons. Things like rubber, plastic, dry air, wood. These are things that prevent the flow of electrons. So these are things, this is why metal wires are wrapped in plastic to insulate them, because that plastic, that's the plastic or rubber that a wire that is wrapped around a wire, is going to prevent the electrons from leaving the wire and you know, dissipating off, because it prevents the motion of electrons. So circuitry. Well, chances are you may find yourself, especially if you're teaching ninth grade or 8th grade rather, you might find yourself teaching electrical currents. You may also find that you do this in certain lower grades and certain lower grades within elementary school. So you have to know the difference between series circuits and parallel circuits. So let's take a look. A series circuit is a single path, as a current is a circuit in which there is only one single path for electrons to pass through. If one part of the circuit goes out, the entire circuit goes out, because everything's moving in one particular pathway. And in order to find the total resistance, you get total resistance from all of the bulbs or all of the resistors in the circuit. in a series circuit. The voltage is divided amongst all the bulbs and so, or anything that's running on this particular circuit, which means that the voltage for each one of them is lessened. Every time you put another resistor in a series circuit, it's going to reduce the amount of voltage across the board. A parallel circuit is different. A parallel circuit is a circuit where there are multiple pathways for electrons to travel. And so as long as there's a pathway for the electrons to travel, the current is continuing to flow. So current flows in more than one pathway. Electrons divide amongst all the separate conductors. One bulb goes out and the rest will stay on, because of the fact that there are other pathways for the electrons to flow. If one bulb goes out, the rest will stay on as long as there continues to be a pathway for the electrons to flow. Current increases when bulbs are added, and then the total resistance decreases when bulbs are added, because as soon as you add another pathway, you reduce the amount of resistance that there is across the whole circuit. So all bulbs across the circuit will have the same voltage, and the voltage of whatever the voltage of the power source is. So here are some study websites, and there's some electricity. Hopefully in class we will have the opportunity to build some circuits, and you will be able to see what that's about. And that's electricity.